All right, everybody, let's take a few minutes here to just kind of review what we've done so far in this chapter. And again, it's all really centering on this idea of graph sketching. So getting information either from the equation of a function or from its graph. So let's start out kind of with the one that pulled it all together. So using a function to answer questions about the graph and ultimately sketch a picture of the graph. So remember, we always start out the same way here. We're going to find our first derivative and find out where that's equal to 0. And that's going to give us the critical points. So let's see, did I do that right? Yes. Okay, so I'm going to factor out a negative 3x. So then I have x. Since this is positive, I have to have a minus 2 here. So it looks like my critical points are at x equals 0 and 2. Okay, so now I'm going to find my second derivative. Whoops. Is negative 6x plus 6. I'm going to find out where that's equal to 0. And that'll tell me where my potential points of inflection are. So now we put this all into our table. So let's see, I have negative infinity, critical point at 0, possible inflection point at 1, another critical point at 2, and then we're on that open interval, so I have infinity at the end. So let's test some points. So I have less than 0. So actually here I'm going to have a positive. This will be a negative, so I'm negative over that interval. Between 0 and 2, I'll pick 1. So I have a negative times a negative makes me positive. And then for anything greater than 2, I'm going to be negative times a positive, which is negative. So now I know f is decreasing here, increasing, and then decreasing. For the second derivative, I just have to check on either side of 1. So if I put in a negative, that's going to give me a negative times a negative is a positive. So I'll be concave up. And then greater than 1 is going to be a negative times a positive, which is going to give me a negative. So I'll be concave down. So let's go ahead and figure some stuff out. Critical points, we said we're at 0 and 2. Points of inflection, since I changed sign at x equals 1, I have a point of inflection there. I am increasing from 0 to 2, where my first derivative is positive. And I'm decreasing, let's see, from negative infinity to 0, and from 2 to infinity. I'm concave up where my second derivative is positive, so from negative infinity to 1. And concave down where it's negative, from 1 to infinity. Now we're going to find the locations of our maxes and our mins. So max is where I change from f prime changes from positive to negative. So it looks like that happens at x equals 2. My minima are going to happen where I change from negative to positive, or at x equals 0. Now, for my absolute values, I have to kind of see what's going on with this function. So we start off, let's see, decreasing and concave up. And then I'm increasing and concave up. Next, I'm increasing and concave down. And then decreasing and concave down. So my graph, it looks like something like this. Now, here's that min we had at x equals 0, and that max at x equals 2. But I can see, for an absolute max, this is going to continue up to infinity. So I'm never going to be able to pinpoint that absolute max. So we would just say none here. Same thing for my minimum. This is going to keep going down to negative infinity. So I can't pinpoint that absolute min either. So this is also a none. So this example was just a little different because it asked us to identify the absolutes as well. All right, let's go get some y values here so we can plot some points. If I plug in 0 to my original function, I get 0. For 1, let's see, I have a negative 1 plus 3, should give me 2. And then at 2, I have a negative 8 plus 12, looks like 4. Hopefully I did that right. So now I'm just going to fit this kind of behavior here to the actual points that I have. And this one's pretty easy to graph. So I just have 0, 1, and 2. Counting by ones there. Oh, I should have given myself more room here maybe. 1, 2, 3, and 4. And please do, when you're graphing these, make sure you include your scale. That's a good habit to get into. On that AP test, you want to make sure the grader knows what scale you're using on your graph. So let's see, I have a point at 0, 0, at 1, 2, and 2, 4. So let's see, I was decreasing and concave up, increasing and concave up, to increasing and concave down, and then decreasing and concave down. So there's a sketch of my graph. Again, it's not perfect, but it gives us an idea of that behavior. All right. Now, we could also pull this information, right? If we didn't have to go through all this, if we were given the graph, this actually becomes now a much easier question. So now I have the graph of the function itself, and I just need to answer these questions about its behavior. So again, if I have the graph of f, critical points are still just where f prime of x is either equal to 0 or is undefined. But since I don't have any corners or discontinuities, I don't have to worry about where it's undefined, just where it's 0. So I'm looking for places where it would have a horizontal tangent. So that's going to be at kind of these peaks and valleys. So I have negative 3. It looks like down here at 1, again at 3, and then down at 6. So I'm increasing where I have a positive slope. Now I'm going to assume this is an open interval here. I don't see real clear endpoints. So from negative infinity to negative 3, again from 1 to 3, and then from 6 to infinity. Sorry, it's squished in there. Decreasing where I have a negative slope. Oops. I also made a mistake here. These should be closed intervals. Sorry about that. You probably caught that before I did. Decreasing is happening from negative 3 to 1, and then from 3 to 6. Okay, so relative minima. Let's see. It looks like down here at 1, this would definitely be a locally minimum value. So the smallest in that region. Oops, I just did minima, so let's put that over here. Another minimum value happens here at x equals 6. For relative maxima, now I can see up here I have a peak at negative 3. I also have a peak here at 3. Now, for this one, for absolute maxima, we have to be a little bit careful. Assuming this is an open interval, this is going to keep continuing up towards infinity. So I could get higher than this local value we found here. So for absolute, I'm going to say there's none. Same thing on my other end for minima. Since this is an open interval, I keep continuing down here. I can't actually point to an absolute min for that function. All right, so the last piece of this we want to look at now is number 3, and now we're looking at how to do this if we have the graph of f prime this time. So you'll find as we work on questions, it's really important before you dive in to understand whether you have the graph of f or whether you have the graph of the derivative. So now, critical points, again, same idea. It's wherever f prime of x is equal to 0. Since I'm given the graph of f prime, I'm literally just looking for the zeros of this function. Now, these are not exact, so we're going to do our best to kind of estimate. So it looks like maybe negative 3.2. And it looks like maybe negative 1.5. I have another 0 at 1, and then it looks like here it's equal to 0 at 6. So let's do all this first derivative stuff first. So increasing is wherever my function is above the x-axis. Okay, and I'm going to assume this is closed here. So we are above from -5 to -3.2, that first critical point we found. Then from -1.5 to 1. And then there's nowhere else we're above the x-axis. So I'm going to make a note for increasing. F prime is above x. And then decreasing, we're looking for f prime to be below x, because we know we're decreasing where that first derivative is less than 0. So here we have, let's see, I called that -3.2 to -1.5. And then again from 1 to 6. All right, so now points of inflection I know are where f double prime is equal to 0, or where the slope of f prime is equal to 0. So again, I'm looking for horizontal tangents of f prime. And again, we're going to do our best to estimate this. It looks like at -2.5, I have a point of inflection. Again here at 0, and then down, I don't know, it's pretty close to 4. Maybe x equals 3.8. Okay, so now concave up is where my second derivative is greater than 0. So I'm looking for where the slope of f prime is positive. And I know that happens here from -2.5 to 0. And then again, I have a positive slope down here from 3.8 to 6. We're going to be concave down where we have a negative slope. So from -5 to what did I call that, 2.5. And then again from 0 to 3.8. Okay, so now for our max and mins, we're going to look at interior points, but we also want to make sure that we consider what's happening at those endpoints. So now for my function, I know since f prime is greater than 0, my function starts off by increasing, which tells me at that endpoint where I started, I actually have a minimum at that value. So I have a minimum at -5. Here I change from positive to negative. So I'm going to have a maximum at my -3.2. Now I'm going to change from negative to positive. I have another minimum at, I think we called that -2.5. Okay. Sorry, not -2.5. That happens at -1.5. I knew that didn't seem right. Let's see. Then we change from positive to negative again at x equals 1. So I have a maximum there. And then let's see. I don't change sign, but at the end, I know I'm below the x-axis, so I'm still decreasing. So wherever that ends, it means I have a minimum at that endpoint as well. So we're going to include that endpoint. So we want to make sure where we have a closed interval, we're checking the input or the endpoints as well when we're doing our relative maxes and mins. Now the other point I wanted to bring up here is we can't actually decide which are absolute maxes and mins. Since this is f prime, we have no way of knowing the y values of these x values. So we can only, if we have f prime, talk about relative maxes and mins and not absolute. All right, so that was a bit long, I know, for a review video, but hopefully we're all pretty solid on this material at this point. We'll be moving on to something a little bit different as we go forward.